All right, so here's our first problem, and it says animals. The Association of Zoos and Aquariums provides information about proper animal care and management. The AZA states that for an exhibit with 6 or fewer emperor penguins, the pool must have a depth of at least 4 feet and a volume of at least 1,620 gallons, or about 217 feet cubed per bird. If a zoo has 5 emperor penguins, what should be the dimensions of the pool shown at the right to meet the minimum requirements? Okay, so we are talking about volume here. So the first thing you want to put on your paper somewhere, let's just note some formulas that you'll come across in doing these. So one of the formulas is your volume formula, which is the one we need for this one. So volume equals length times width times height. All right, so we're going to use the information, variables and numbers or expressions that they've given us to create an equation of using the volume. So the first thing we have to do is go and look at so our steps to solving these word problems. First thing is to create your equation. After you create your equation, your second step to solving it, you're going to graph your equation. And then the third step, you can then solve the problem. So in creating this equation, we're going to take our volume formula. And here we can see we have our length, our width, and our height, or length, width, and height, whichever way you choose to look at it. And then the volume, they tell us that right here, they talk about the volume. It's 4 feet is the depth, and the volume has to be at least 1,620 gallons. So we could use that, or we can use the or part, which they tell us 217 feet cubed per bird. So I'm going to use this one. And it tells us that that's per bird, right? 217 feet cubed per bird. But we have 5 birds, or penguins. So we want the volume, right? Because this is all talking about volume. We want the volume to be 217 feet cubed per bird, but we have 5 birds. So we're going to do 217 times 5. So that way we can figure out what we want the volume to be here. So we want 1,085 for our volume. So now we can use this equation. So we are going to do, I think I'm going to run out of space. We're going to do length times width times height. So we have our picture over here showing us the length, the width, and the height. And we are going to use them just as they are, even though they have some, they have a variable. They all have x in them. That's fine. We know what to do with that. So we're going to take the volume of 1085. And we're going to create an equation. Another space. So we're going to have 2x, right, times 2x plus 3 times 5x minus 2. And I want it all equal to the volume of 1085. Right, so that is the beginning of creating my equation. Now, I could put this into decimals just like this, but most of the time they like to see this all multiplied out. So if we were to multiply this, we would distribute this first multiplication, right? And I'm not distributing 2 to everybody. I'm just going to multiply it to what it's directly next to. So I get 4x squared plus 6x. And then I'm going to bring the remaining part of the equation down, 5x minus 2. Then I'm going to multiply that part. So 4x squared times 5x is going to give me 20x cubed. And 4x squared minus times negative 2 is going to give me negative 8x squared. Then 6x times 5x is going to give me 30x squared. And 6x times negative 2 is going to give me negative 12. And I can combine like terms here. Negative 8 and 30 is going to give me a positive 22x squared. And just bring down everything else. Okay, so now step 1 is done. We have created our equation using volume because that's what the problem is about, the volume of the pool. And now we are going to graph the equation. So here's where we go over to decimals, and based off of whichever graphing method you like best, you do. So over here, I already have them set up. Hopefully you can see. I'll erase most of this for you. Okay, so I already have them set up. So one of the ways, remember, is if you create your equation, set it equal to 0. And then you graph it and look for the x-intercepts. So there's my graph. My x-intercept is here. So my answer is 3.5. Right? That is when you set your equation equal to 0. So we would subtract 1085 from both sides. Or if you like the other method, when you use a system, you grab everything before the equal sign first, and then you grab everything behind the equal sign separately. And keep in mind, if it is just a constant with no variable, you have to create it as a function. So you put in y equals 1085. Now 1085 is very far up. So here's where we need to zoom out until we see that there. And there is our intersection at 3.5. So whichever method you like, you still get the same answer. So 3.5 is our solution. So that's what we get from our graph, is what x equals. So say, okay, x equals, x equals 3.5. Try it again. X equals 3.5. Okay. And so then that's our graph, and we got what x is equal to. And so 3 is solved. So I have to go back into the problem to see what is it that I'm solving. So it says, what should the dimensions of the pool shown at the right be to meet the minimum requirement? So what should these dimensions be? Instead of 2x, what should that be? So now that I know what x is, I'm going to just plug it into each of the dimensions to figure out what they should be. So the first one, I have 2 times 3.5. That first dimension should be 7. Next, I have 2 times 3.5 plus 3. So I have 7 plus 3. That dimension should be 10. Next, I have 5 times 3.5 minus 2. So I have 17.5 from here minus 2. I'm going to have 15.5 should be my other dimension. So that is the solving part, is going back and plugging in what you found for x. And so that's what x should be. Questions?